So today we're going to simplify radicals with variables. I guess it would help if I showed this to you as well, huh? All right. So we're just going to add some variables inside into the root to what we did yesterday. So nothing really changes. We're just adding some letters. So this is a pretty short, sweet, to the point lesson. Okay. So simplifying radicals with variables, 7-6. Again, these lessons don't necessarily match up with the book. All right, I kind of went off base with these, or off the book's track. Simplifying radicals with variables. Like I said, it's essentially the same thing as what we just did. I'm just going to include variables now. All right, so here's the first problem. 40x to the third, y to the fourth. Now, I still want to break down my 40 exactly like I did before. So 40 breaks down to what? 2 and 20. 20 is 2 and 10, and then 2 and 5. So what, 3 2s and a 5? Okay. So 40 is 2, 2, 2, 5. Agreed? Now, for this first one, I'm going to write out the variables as well. So if I have x to the third, that means I have x, 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 right? Y's, I have how many? 4. 1, 2, 3, 4. Now, this is just a square root. So square root, I'm looking for pairs of 2, right? So I got a pair of 2's out front, got a pair of x's, and I have 2 pairs of y's. Everybody see that? So that means I pull out 1 for each group on the inside, correct? So I'm going to have 2, 1x, y's, I have 2 of them, right? Y squared. Okay. Y squared, just like that. Now, square root with what's left? Well, I have a 2 and a 5, so that's 10, and then I have 1x left. Oops, just 1x. Okay, so nothing really changed. Just threw them extra letters in, right? Well, you have to be, some of the things you have to be careful with. You have to be careful that, well, one, that you can count right. Two, you don't have to write out all those letters inside if you don't want to. You don't have to write out 3 x's and 4 y's and underline them if you don't want to. You can look at that and say, all right, well, 3 is 2 and 1, so it's a group of 2 and 1 left over. And y's, there's 2 groups. That's perfectly fine. Okay. All right, let's do one more. Let's go. Oh, let's go. We'll do one more together, then I'll set you loose. Let's do.
Well, let's do 77 x y 4.
Let's go. 2x, 45. We're going to go x to the. All right, we'll go 7ths. And y to the 5th. So, 45. What's 45 break down to? 5 and 9. 9 is 3 and 3. Okay? So, again, I'm just going to kind of ignore this guy for right now. Just like I told you before. Go ahead and ignore what's on the outside. Bring it in the last step. So, I have on the inside, I'm going to have 45 is 3, 3, and 5. And I'm not going to break down this x and y if that's all right with you guys. Okay? So, what can I bring out front? Well, I can bring out a pair of 3s. And I already have a 2 out front, so 3 times 2 is 6. X's. How many groups of x's can I bring out?
3.
I can bring out 3 groups with 1 left over, right? Okay, so I have, I'll put that 5 in there because I have him left over. So then x's, I have 3 groups, and I already have 1 more out front, right? That gives me how many? 3 plus 1 is 4, with 1 x left on the inside.
But you've got 2.
Y's, I have 5 inside. That's 2 groups of 2 with 1 left over. All right? 2 groups, 1 left. So you have 6x to the 4th y squared root 5xy. Yes.
How do you get that? Like you got 2x on the outside.
I have 2x, not x squared.
Yes.
This
never mind.
does not equal this. So all I did,
Stays up there.
all I did, I set aside that 2x. I broke down what's inside the root for the 3, 3, and 5. X's, I had 3 pairs I could bring out, 1 left over. Y's, I had 2 pairs I could bring out, 1 left over. And I had a group of 3's I could bring out. So then I just multiply those 3 things. If you want to, I can write it like this. I had 3 x to the 3rd, y to the 2nd. That's what I brought out. So I have that times 2x. 3 times 2 is 6. X's I'm going to have 4. Y's I have 2.
Yeah, but anything times 1 is the same number.
Yeah.
So x.
Okay, it's the power rules we just did. This is 1. Combine like terms. 2 times 3 is 6. X's. 3 here, 1 here is going to give me 4. Y's is 2. Yeah, it's exponential rules. We just did this. It's the beginning of the chapter. Multiplication, you add exponents. Quit kicking the table. Guys, this is all related. All related. Exponents, roots, everything is related to each other. That's why I group them together. Okay. Here you go. It's 4 problems. on the first one, there's no numbers we can bring, no big numbers we can bring out, is there? 'Cause 5 doesn't break down. 5 is a prime number. All right, so it's stuck. X's, I have one pair of X's I can bring out. Y's, I have two pair. Z's, I have one pair. So I bring out my X. I bring out two Y's. I have a pair of Z's. And then that leaves me with 5 X, Y, Z on the inside. So we got the first one right. Good. Second one, it's 27, so that's 3 threes, correct? Okay, so I have a pair of threes I can bring out. A's, I don't have any that I can bring out. B's, I have 2 of them that I can bring out, 2 pairs. All right, so I multiply stuff together. I'm going to have 3 times 3 is 9. And then I have X, and I have 2 B's. Okay, it doesn't matter. It's multiplication. All right, so you could have 9xb squared, or you can have 9b squared x. You just have to make sure your number's on the left, your big number. Okay. All right, then left on the inside, we should have a 3 and an A.
Don't forget about the smiley face.
And an A. All right, that one is correct as well. Okay, number 3. So 16, I'd have 2 sets of 2s to bring out. M's, I'm going to have 2 sets of M's. N's, I'm going to have 2 sets of N, or 3 sets of N's. Okay, so I'm going to have 2 and 2 is 4. So I have 4. M's, I have 2 of them. N's, I have 3 of them. Left on the inside then is an M. Correct. All right. Last one. Number 4. 32 has 5 2's. So that's going to be 2 pairs of 2's to bring out. Okay. Then from there I have 2 pairs of M's and 2 pairs of N's. Sorry, 3 pairs of N's. All right, so I'm going to have 2 times 2 is 4. I'm going to have M squared, and then I'm going to have N to the third, leaving me inside with a 2 and an N. Now I also have that 2N out front, right? I'm going to bring it back into the fold now. 2 and 4 is 8. M's, I still have 2. N's, I have 1 here and 3 here, so I'm going to have N to the fourth, square root of 2N. Yep, number of sets. Yep, number of sets. Okay? Questions on that, guys?
Yep.
Now, the only thing that could possibly be different with this is, again, what if I put a different number other than a square root? Okay? I'm just going to look at this last one. I'm going to put a 3 in here. Okay, so now I have that little 3 in that box. That means I need groups of 3 now to bring stuff out, right? So let's do that again. Same thing, 32 has 5 2's, right? So I have 1 pair of 2's I can bring out. M's, I have 1 group of 3. N's, I'm going to have 2 groups of 3, right? So then on the inside, I'm going to be left with 2 2's now, which would be 4. M's, I'm going to have 1 left. N's, I'm going to have 1 left. And then I still have the 2N out front to multiply. That would make this guy 4M N to the third root of 4MN. Okay, so all it just changed was the number of things I had to have in my group. All right. Questions on that?
Nope.
Anybody?
Nope.
Okay. That was the first part. Let me stop there.